When we talk about formulae in algebra, it has to do with creating a rule that can help us to solve specific kind of problems. It usually helps us to also be able to get the answers or the predicted answers to a particular problem. For instance, I am given a rule at the moment and I was asked to find what will happen to this number if five quantities are involved. What is going to be the price? An example is that one. Now, on the board, we also have some nice examples to explain the rule. Write a formula for each of the problems given. Use y equal to 3 and z equal to 5 in each case to test the formula generated. Our work is to generate the formula. So to do that, let's look at case 1. Case 1 says Adam orders for pizza, which costs p pounds and a constant delivery fee of 0.75 pounds. Write a formula to show the total cost of one pizza and 4 pizzas. First, we are expected to write a formula, not a number. That is the first thing we are looking for. Therefore, go back to the problem to know what formula are you writing. You are writing a formula for the total cost. Can you see that? So we are going to start by saying total cost is equal to, you get the point. Therefore, let us use the letter C to represent total cost for the first case where we have just one pizza. Since we're dealing just with one pizza, we come back to the problem. It says he orders for pizza which costs p pound. P pound is written as 1p. P is the price of the pizza. So since we're dealing with one pizza this time, it's going to be 1 times p, isn't it? 1 times p is p. So we leave it as p pound plus what is the other constant term? The delivery fee, 0.75. 0.75. We have solved the first problem. So the cost of buying one pizza will go with this rule. The second one says 4 pizzas. Before showing you how to represent 4 pizzas, watch something. Did you notice that the question says that the delivery fee is constant? For it to be constant, it means that it does not change. It doesn't matter the quantity of pizza you buy. When you buy 4 slices or 4 full pizzas, you are going to pay the same amount to deliver it. If you buy just 1 full pizza, you are paying the same amount for the delivery. It makes sense. Therefore, for 4 pizzas, this is the formula we use for 1 pizza. But this time, the pizzas have increased to 4. What it implies is that although the delivery fee will remain the same, the price will change. This was the price for 1 pizza. When they become 4 pizzas, that is 1 add 1 add 1 add 1. Or just multiply the price of 1 by 4. Therefore, the total cost of buying 4 pizzas will be, we're multiplying the price by 4. 4 times p is 4p. I told you how to write this. 4p is the same thing as 4 times p. You can check back our video on expression to know this, or on substitution. Both of them will explain. So 4p plus the constant amount of delivery fee, 0.75. This problem is solved. So we have ended up writing the formula for the cost of 1 pizza and the formula for the cost of 4 pizzas. Our case 2 is a rectangle. The rectangle has length z and width of y. We are asked to find the formula for the area and the value of the area also, and the formula for perimeter and its value. In this case, what we know as the area of a rectangle is the normal length times width, or length times breadth. I know you know this. And your unit ends up being centimeters squared. That's correct, yeah? So this time around, since the rectangle we are given has our length as z and our width as y, we are going to change the values. We are going to substitute for L and W to become z and y. Therefore, I'll simply erase L times W and replace them with z times y. Your unit will still end with centimeter squared since you are dealing with area. Having done this, you can actually remove the multiplication sign and write it as zy or yz. Remember when we did the other video on expression, I told you that when you are multiplying two letters or two symbols or even a constant and a letter, you can write them together without the times sign. It simply means you are multiplying one by the other. In case you did not see that video earlier, you can go back to see it. Okay, let's proceed. Now, in the beginning of this problem, we were told that when we create any expression that has y and z, we should replace y with 3 and z with 5. Therefore, the z I have here is going to be replaced with the number 5, while my y takes the number 3. That is 5 times 3. So it means that the area of this rectangle is 15 because 5 times 3 is 15. The unit is centimeter squared because that's what we have in the beginning. Done. Let's look at the perimeter. As you know, perimeter has to do with two length and two width. Since our length is z, initially this is what we know the formula to be: 2 length add 2 width. Or you can just write 2, open a bracket, length plus width. You know that already. So our length here is z, which means that it's going to be replaced with 2z add 2y. That's our width. But in place of z, 5 comes in, which means 2 times 5. 2 times 5 is going to give us 10, yeah? So 2 times 5 is 2 times 5 plus 2 times, what is y? Our y is 3. 2 times 3. Now if we work this out, 2 times 5 is 10, add 2 times 3, which is 6. You end up having the answer 16. But 16 what? Is going to be 16 centimeter. Remember, each time you are solving area or perimeter problem, the unit should not be played with. You should always try your best to remember to write down the unit. So we have also solved our problem on perimeter. Now let's look at the last case. The last case is a case of sequence. Sequence is a set of numbers or a set of expressions that have similar distances from each other. All right. We have number of children here: child 1, child 2, child 3, child 4, child 5, child n. And then you notice that as the number of children are increasing, the number of pen given to each of the children is also increasing. Our expectation here is first, when c, that is when we are at child 4, find p, find the number of the pen. That will be also. Now, merely looking at this table will show you a pattern that the table is maintaining. When the number of children kept on increasing by 1, by 1, by 1, the number of pen kept on increasing also by 3, by 3, by 3. So somebody might choose to say 5 add 3 is 8. 8 add 3 is 11. So 11 add 3 is going to give you 14. Somebody can fill in here for 14. Let me use the blue pen to differentiate the ones we are solving now from the ones given to us. All right, 14. Yes. If you did it this way, you are making a lot of sense. So I can easily say that when C is 4, P is equal to 14. That is correct. Not a bad one at all. Next thing we can look at, the fifth one. Since we kept on adding 3, 3, 3, I just need to add 3 to 14. And if I add 3 to 14, that will give me 17. That is also correct. But this time, let's see how you are going to solve the next problem. P is equal to 17. Okay, done. Now, let's see if what we have just done on this board will help us to find the value of P when C is equal to N. This case requires us to show the rule. Now, for us to be able to show this rule, there is something important. In fact, what we have done so far on the board may not help us to find the rule. So we have to think in another style. Because if I decide to find the value of n, one of the things I can say n will now become 17 plus 3. That is n. But that's not true because n is not number 6. You can't say 17 add 3. It is only if n is told, if only n we know the value of n, that will be when here will be known. But this time, n is a letter. For us to be able to find n, we have to rethink in another style. So let's see if there is another way to get this value. Now look here. Did you notice that if I multiply the number 1 by 3, it's going to give me 3. Then add 2 to that 3, I'm going to get 5. Let's test it for all of them and see if it's working. 1 times 3, 3. Plus 2, 5. 2 times 3, 6, plus 2, 8. 3 times 3, 9, plus 2, 11. 4 times 3, 12, plus 2, 14. 5 times 3, 15, plus 2, 17. It's working. So what it means is that for us to find P in this case, it simply implies that P is equal to the number of child, that is C, the number of a child we have, which is C, multiply by 2 first, and then after you have multiplied it by 2, are we multiplying by 2? No, we're multiplying by 3 because it's 3 times 3 we saw there. So multiply it by 3 and then add 2 to it. Add 2 to it. You can also enclose this in a bracket. So this can be written as C times 3 plus 2. That is the rule that we are following to work. So if I want to rewrite this formula, the number of a child now we are looking for is C is n. So I'm going to remove this C and replace it with n. If I remove this C and replace it with n, because the question says when C is equal to n. Now C is equal to n. So the rule we can use to solve this will be P will be equal to n times 3 plus 2. That is the rule. To replace or to rewrite this equation, we can also do it like this by writing n and 3 together so that it becomes 3n or n3. Though the convention is to write the number first before the letter. Therefore, I'm going to write here as 3n then plus 2. Let's rewrite it quickly, as that has given us the rule we are looking for. So P will be the same thing as 3n add 2. This is the rule that we are looking for. So it means that when C is equal to n, the P we are looking for will be 3n plus 2. Whatever the value of n changes to, we'll get the answer quickly. Did you get this really right? So let me ask you a question. What if I change the value of n to 16? What will be P in that case? Simple. 3 multiplied 16 is 48. 48 plus 2 is 50. It means that for child number 16, the number of pen is going to be 50. Did you enjoy this class? You can see this video again, try pausing it along the line, and try to work it out yourself to see how much you have understood so far. Thanks again for watching. Watch out in the next video where we introduce equations.